Okay, if we write p bracket z, okay, to represent a polynomial, the degree of the polynomial is the number that's the highest power of z. So have a look at these examples. If p to the power p of z equals z squared minus 2z plus 3, the highest power is the 2. So this has degree 2. And the next one has degree 3. Okay, so a couple of theorems that we'll need to use in this chapter. Okay, the factor theorem. If p of a equals 0, then z minus a is a factor of p of z. Okay, and this is telling us that whatever that number is, a, that is a root or a 0. Okay, for example, in this one just here, if you substituted for z, if you substituted the number 2, you would get 2 cubed is 8, minus 2 minus 6 is 0. So that means that 2 is a root or 0, and z minus 2 is a factor of this one. Alright, and the opposite is also true. If you know that z minus some number is a factor, then when you sub that number in to the function, you will get 0. Okay, so if we knew that we were given that z minus 2 is a factor here, that would tell us automatically that if we sub 2 in, we're going to get 0. Okay, the fundamental theorem of algebra. This says if p of z is a polynomial of degree n, it has n roots. And they're not necessarily distinct, which means they all could be the same. Okay, so for instance, we had z cubed plus 3z squared plus 3z plus 1. This, all roots are minus 1, I think it is. Okay, because this is the same as z plus 1 cubed. Okay, so it has 3 roots, but they're all minus 1. And this is telling us also, it tells us that in these examples here, this has degree 2, so this has 2 roots, and each time it has a root, that means it has a factor, z minus that root, so you can factorize this into 2 sets of brackets. Okay, you can factorize this one into 3 sets of brackets. Okay, it has 3 roots. We already know what one of them is, but it has 2 more. So let's have a look at an example. Okay, here's our example. We're given a polynomial. It's degree 3. So we know right away that this can be written as z minus some number, z minus another number, z minus a third number. Okay, I can factorize it 3 times. This a1, a2, and a3, which may or may not all be the same. Okay, so, and I'm actually told, okay, if minus 1 is a 0 of p of z, find the other zeros. Okay, so this has told us that one of these is a minus 1. Okay, so this equals minus 1, the first one. So we have to find the other 2. Alright, so if z, one of the roots is minus 1, we know that z minus a minus 1 is a factor. Okay, so this p to the of z is going to be equal to z minus a minus 1, which is a plus 1, times some other polynomial. Okay, and this polynomial has to be 1 degree less. Okay, it's going to be a z squared, a degree 2 polynomial. Okay, this has to be a degree 2 polynomial because we've got 2 roots left to find. This is a degree 2 polynomial. Alright, so there's a couple of ways you can solve for this. One of them, let's try it this way. Okay, this is going to be some number of z squareds. some number of z's and some number, just a number. Okay, we'll do a different method in the next example. Okay, so we need to find these numbers, and then we'll need to factorize that. Alright, so when we expand this z plus 1 times all of this, okay, let's expand that. We're going to get, let me try it out, z plus 1 times pz squared plus qz plus r. And this has to equal, once we expand it, it has to equal this. So all the coefficients have to be the same. Alright, so let's times this out. So z times pz squared is pz cubed. Z times qz is qz squared. Z times r is rz. Let's move on to the 1, and then it's just 1 times, so these don't change, these next 3. Okay, equals all of this. And let's just combine like terms. So here's my, I've only got one z cubed. I've got a q and a p to go with the z squared. And I've got an r and a q to go with z. And then I've just got the r on its own. Okay. So the coefficients now on the left side have to match the coefficients on the right side. So what that means is this p here has to equal however many z cubes I have there, which is 1. Okay, so we know that p is equal to 1. Then we can look at this q plus p, the coefficient of z squared has to equal this 3. Okay, so we've got q plus p equals 3. Well, we know that p is 1, that means q has to be 2. We'll look at this one, the r plus q has to be equal to the 11. R plus q equals 11. Q is 2, so that means r is 9. So we've actually got all our numbers. We've got the 1, we've got the 2, and we've got the 9. P, Q, R. And just double checking, we've got the fourth one. We just make sure that we've done everything right. R equals 9, and which we've already got here. Okay, so that verified. Alright, so we've got our factors. We've got so P of Z equals Z plus 1, and then P is 1, so that's Z squared. Q is 2, so we've got 2Z squared, and R is 9. Okay, so we need to factorize the second one. So we're going to use the complete the square from the last video. So we're going to have Z squared plus 2Z squared. We're going to have a plus 1, that's half of the 2, which is 1, and then we square it. We've still got the 9, and then we have to minus a 1. Okay, so we get Z plus 1. We'll put square brackets here. This becomes, these 3 become x plus 1 squared. And then I've got plus 9 minus 1, so that's a plus 8. And Z plus 1, and this is x plus 1 squared, so we have to write this as difference of two squareds. So this is like a minus 8, which we square root and square, which gives us Z plus 1 x plus 1 squared minus, and this is the square root of 8i squared. So now we've got difference of two squares here. Z plus 1, it's not, oh that's 1. And difference of two squares, so we've got, why did I put x? It should be Z. Z plus 1 minus square root of 8i, Z plus 1 plus the square root of 8i. Okay, so I've factorized, those are my 3 factors, and my 3 roots are, remember it's the opposite sign of whatever these are, so this one is a minus 1, this one becomes a minus 1 plus the square root of 8i. And the last one, the negative of this, is negative 1 minus the square root of 8i. Okay, next example.